So welcome everybody. Thank you for joining us, the Blackstone LaunchPad, for our third workshop event, Designing Thinking. My name is Honorary Clark, if you haven't met me already, and I'm co-hosted by Andrew and Hadar today. Me and Andrew are both student assistants, and we will be hosting Dan Buckmeister today. We are from the LaunchPad, which is located in 220 SU, who deals with encouraging and developing entrepreneurship and helping people grow their startups or be contributors to their startups. So let me just pull up a little slideshow or a slide about Dan real quick. This would work. Oops. Not that button. All right. So Dan Buckmeister, Buckmaster, there you go, is our workshop person today. He's the president of Tresca Design, former Western New York Prosperity Fellow, project and product engineer at Moog Aircraft, and also an alumni, if you didn't hear before when he was talking about Hadar, but he's an alumni of UB, BS in 2018 and MS in 2020. Oops. And I will pass it on to Dan.
Awesome. Well, thank you for the intro. Let me get my PowerPoint up, if you'll allow me to screen share.
Yep.
And can everyone hear me okay? Perfect. Okay.
Screen share now?
Yes. Okay. All right. Can everyone see my slides okay? Perfect. All right. Well, thank you everyone for attending here. My workshop today is going to be about design thinking for entrepreneurs. So assuming everyone here either is an entrepreneur, wants to be an entrepreneur, or wants to support and work with and add value to a fellow entrepreneur, my talk is really going to be about how you can think from a design perspective. So first, a little bit about us, which is my company, Tresca Design. I founded the company in 2017. As mentioned, I am an alumnus with my bachelor's and master's in mechanical engineering, both from UB. We're a company of 8, and we're a team of engineers with design and manufacturing experience. The company has 2 divisions, Tresca Design, which focuses on product design, prototyping, 3D printing, and then Tresca Manufacturing, which supports turnkey manufacturing, supply chain, operations management services. We do work in many different industries: automotive, medical devices, automation, test fixtures. So generally, you can think of us as the engineering firm that makes outsourced engineering easy for people. So what I'd like to talk about today is are a few things here. So first, what's in the design process? You've already heard me mention this a few times. What's under the hood there? Next, where can you get stuck? Where is it most common for you to get stuck? Also, what does this look like in a real sense? It's great if I give you slides that talk about everything that is all theory, but if I don't give you an application, it's not really going to carry much weight. And then lastly, arguably the most important question, how can you adopt this in your startup? So let's jump into it here. So when I say design process, this is a design process that we use at Tresca, and it's pretty common to many, what I'd say, standard design processes that are in engineering. So starting with concept generation, this is kind of figuring out what this general concept is going to be. You move over into your proof of concept, which quite literally is proving out that that concept is going to work. CAD modeling is making your concept into something 3D. Simulations analysis, this is a way that you can validate your design without really doing some physical testing. And by the way, we're going to go through these in detail, so don't feel like you have to soak up a busy slide right now. Prototyping, this is, I think everyone knows what this is, but a physical representation of what your concept has become. Next, you have to make sure that whatever that prototype is, you can actually manufacture it in however many batches you need, 10, 100, 10,000, a million. And then we get into supply chain and manufacturing, which, as I mentioned, isn't truly part of the design process. It's more part of the product development process, and that's a separate side of the business. So let's kind of walk through the major steps here. So concept generation. The keys here are understanding who your customer is. Is it an individual? Is it a group of people? Is it a company? Is it an industry? Who are the people that are going to be using this product? Those are the most important people in this entire process. With that, you need to determine their need. They're not going to buy a product from you if you're not fulfilling a need that they have, right? Or want. Next, you also need to define the customer's requirements and constraints, which I'll talk about in depth a little bit later. And then also you need to start to develop various concepts. My advice here is don't rule anything out yet, get creative. Something that we're very good at here is kind of thinking outside the box, coming up with those creative solutions. The whole yes and mentality. Anyone that's ever taken an improv course knows the yes and mentality. When you hear an idea, if it's not great, okay, add something to it. Keep on adding, and even the silliest concepts can sometimes give you these little nuggets of things that end up becoming your final product. And lastly, refine your ideas. Use a decision matrix. Have a way of rating, whether this is writing your concepts on the board and your team, your advisors, your friends put post-it notes next to the concept they like best. Try to have a way to take all these ideas you've generated and boil it down to one concept or maybe a couple concepts that you're stuck between. That's how you can go from this problem and this need that a customer has into tangible concepts that you're able to represent. So next is the proof of concept. What are the qualities of a proof of concept? Some people get this confused with a prototype. Well, a proof of concept is to quite literally prove that your concept works. It's great that you had this idea, but is it feasible at all? These should be cheap, these should be fast, these should be effective. This isn't something that you're going to bring to an investor, most likely. This is something for you to convince yourself that you should continue to invest your time in this opportunity, in this company, in this project. Two common types of proof of concepts that we use here at Tresca: a functional prototype, which is basically the mock-up of your system, of your product, of your machine, whatever that is, that frankly looks terrible. It's not supposed to look good. It's not supposed to be cheap and sleek. It's supposed to show you, hey, you had this idea that this machine takes A and produces B, and it does it. Another way that we use these proof of concepts are piecewise prototypes. Right now, we're developing a machine that is for manufacturing automation, and it has 4 discrete steps. Before we could even get into the detailed design of that, we needed to prove out the concept. So we actually made 4 different proof of concepts so that we could test each one piecewise and individually. Much cheaper, much quicker, and actually much more effective. Again, what a proof of concept is not used for: marketing and aesthetics. Sometimes if you're going for an investment, they want to see that, hey, you've thrown some math at this, but it's not going to look pretty. And frankly, that's what you need for marketing. So I do want to take a pause here and touch a little bit on intellectual property, because this is incredibly important, especially if you are developing a physical product. Not all products that you develop can be patented or should be patented, but it's important to take a pause and understand that first. So, disclaimer here, I'm not an attorney. I'm someone that has worked with patent attorneys, that has worked with clients that have gotten things patented, excuse me. I have a few patents under my name, so I'm kind of just sharing some tribal knowledge here, if you will, but don't consider me a patent attorney and don't sue me, please. So let's talk just a little bit about patents. There's 2 primary types of patents: a provisional patent and a full patent. A provisional patent is good for 1 year. It's much cheaper, it's much easier to file. It basically protects your idea for 1 year and buys you that time to figure out, is this something you want to move forward with or not? Full patents are exactly what you see registered. They are standing, they're permanent, at least until the time expires on it. But once you get granted that patent, you have it. A lot more expensive, a lot more time consuming. Sometimes this takes 1 to 3 years before the patent is actually in your hands. In full patents, there are 3 different classifications. There is a design patent, a utility patent, and then a plant patent. So obviously we're not going to touch on the third one. It's exactly as it sounds. You're patenting a type of plant. So let's talk about a design patent. This is quite literally patenting the physical design of something, the way it looks, not the way it functions. An example I'm showing here is a Coca-Cola bottle. There's nothing unique about this bottle. It's something that holds liquid, right? That's been invented. The use isn't anything special. What is special is that design. So Coca-Cola patented that so that no one else could use a bottle that looked like that. That was important because now no one can make a copycat Coca-Cola with a little bit of a different brand to it, right? Or a different logo. What we work on as engineers most commonly are utility patents. So this really doesn't touch on how something looks. This focuses on how something works. What are the core fundamentals of the science of the mechanisms? Right here, I have the airbag assembly as an example. This isn't a patent telling you how the airbag looks. This is simply telling you how it works. What is the mechanism behind it? How is it used? So the question, can a product have both a design and a utility patent, or can you only have one? Well, the answer is yes. Look at the iPhone. The iPhone has over, I think I tried to look this up. I couldn't get an exact number, but it's well over 200 patents just in the iPhone that's in your hand. There are patents on all of the different technologies, wireless, Bluetooth, the way the screen is, a lot of the technology. In addition to how the phone works and is used, there's also design patents. There's a reason that you can't buy a phone that looks identical to the iPhone, right? The curves, the layout, the cut of the screen, all of those things are constantly being patented. So Apple is protected from people not only copying how their phones work, but how they look. So I know that that is an extremely quick mini workshop on patents, and this is very deep water. I wanted to bring this up because this is something that should be in the forefront of your mind. Specifically to all of you, your venture coaches can definitely help you, can definitely help point you in the right direction here. Also, I'd encourage you to talk with Hadar about the e-law center. They can provide you some legal counseling at a significantly reduced or sometimes even free fee. So that's my little break on IP. I'll pause there for a second. Does anyone have any questions on what I've gone through so far? Cool. We'll keep going then. So, okay, let's get back to our process. We've gone through concept generation. You've proven your concept. Okay, now you need to make a prototype. Well, how are you going to do that? Depending on your product, you can probably use CAD software to design those concepts that you've come up with. This allows you to visualize it in 3D to help you spot potential flaws or oversights that maybe your back of the napkin sketch or playing around with cardboard and McMaster parts couldn't find. This also allows you to run simulations on the test, which I'll talk about next, to test the product in various environments. What's important here is especially when you have components that are coming together, you see a drone on the left, a bottle opener on the right, or a corkscrew rather on the right. Having your components interface is extremely important. That's something that's very difficult to just plan out in your head. Putting it in 3D models allows you to move things, see how they're going to interact, see how they're going to work with one another. Some notes on CAD modeling for UB engineering students. I know that you definitely have access to SolidWorks, and I believe you still have access to Creo. Between me and the people on this call, use SolidWorks. It'll make your life a lot easier and you'll be happier in the long run. Regardless of what school you belong to, Autodesk Fusion 360 and Autodesk Inventor offer free student licenses. So you do have access to pretty good CAD softwares that you are able to get for free as a student. So, okay, I've mentioned a couple times simulation and analysis. Why is this important? Why do we want to do this? Well, iteration is expensive, not only in the materials to make a prototype, but also your time. The more time that you have to spend continually going back and forth and redesigning, that is arguably your most valuable asset, especially as an entrepreneur on top of being a student, right? You guys are already sleeping 3 hours a night. You can't afford to keep going at this. In addition to that, prototype costs can be high, as I mentioned. Sometimes you're going to spring for a $1,000 prototype because it's really going to get you what you need. Well, especially as a student, if you're going to spend $1,000, you want it to be correct. So when I say simulation and analysis, it's not always something you do on a computer. Physical testing is great for projects that don't have loads. What I mean by that are you're not putting weight on them, you're not putting stress on them. They're pretty simple everyday tools. This is a good first step. And even if they do have even if they do have loads, if you're able to make something cheap and easy and you can actually drop it and see if it cracks, or you can actually bend it and see if it breaks, that's always a good first step. It'll save you time. But again, we want to be cost conscious here. We want to focus on economical solutions. What I'm showing to the right here is an FEA computer simulation. So when physical testing isn't feasible because of cost or size, or just there's no way you can put 2,000 pounds on this thing, you don't have a way to get 2,000 pounds. This is where you can simulate different things like drops, loads, things bending, thermal simulations. This is very deep water and takes a lot of training. The good news is with a lot of CAD packages, this is actually a free tool that you can use and learn. And I know all of my UB mechanical engineers, you'll at one point have at least 1 or 2 classes that will teach you the very basics of FEA simulations. So, okay, we've gone through the overall design process, right? We simulated it, we're confident, we want to keep moving forward. Now we need the prototype. The purpose here, you need to sell others on your idea. You need to show them that it's feasible, that it looks nice. And there's a couple different ways to do this. So let's start with rapid prototyping. This is quick and easy. It's really meant for verifying concepts. These are 3D prints, and generally you're going to throw them away after you use them. They're not going to have a lot of functional value. Maybe you make your product that gets 5 uses out of it, and then it's not really going to be useful anymore. Of course, this is all relative, right? We've 3D printed things that have been used in the field for 3+ years now. All depends on the context, but this is definitely a quick, easy, and relatively cheap method to get a prototype off the ground. Another type of prototyping that we engage in is what we call evolutionary prototyping. So if we have a project that is pretty complex and it has multiple stages to continue to refine the product, after each design stage, they're going to give us input to revise the concept, and then they want another prototype to see it. They're going to take it, they're going to put it in their field, share it with their customers, and then they're going to come back to us with a whole nother list of changes, rinse and repeat until the product satisfies both our customer and whoever their customers are. And then for larger products that have a lot of sub-assemblies, incremental prototyping. So this is where you start to prototype bits and pieces with the intention of eventually making your big adult-sized Lego and bringing everything together. In terms of some low-end, high-end prototypes for you to consider, on the lower end, you can get a really, really nice 3D print at professional quality. It's going to cost you a little bit more than just your friend printing out of their dorm room, but it's going to get the job done. It's going to have a really nice finish. On the incredibly high end, you can get something molded and machined that will actually 100% mock up what your unit is going to look like once you're in full production. Obviously, you get what you pay for. So this can definitely be a very, very expensive option depending on what your product is made of. So once you've prototyped it and you have the interest you need or the validation you need to continue to move forward with your process, you need to recognize that what you have in your prototype and what you have in CAD is a lot different than what comes into manufacturing. And not only can this mean that your design may not be manufacturable, it may mean that it's just really expensive to manufacture and you need to look at different ways to get it manufactured. 3D printable designs, especially, don't always transfer well to standard manufacturing techniques. One of the downfalls of using 3D printing as a core of your product development process is you can make all of these cool parts, all of these cool geometries, and then you go to send it off to a machine shop or an injection molder to get it quoted, and you get laughed at because it's physically impossible or insanely expensive. So this is an important step to kind of check and see, okay, is this going to fit within my budget? Do I have too many custom parts? Are there ways that I can simplify this? Is something not manufacturable? Do I need to tweak the design? So this is definitely something to think about. Also, this is where you really start to introduce how the product is going to get manufactured. What's going to be molded? What's going to be machined? Are things going to be casted? Certain things like that. And then lastly, of course, you went through that whole process. Now it's time to actually get it done. Supply chain, procurement, manufacturing, a lot of different words for the basic sense of how do you go from something in your head or in a computer model that is then sitting in a warehouse somewhere or just in your garage. So a couple things to mention here. Sourcing. This is one of the most important pieces because where will your parts be coming from? Who will make them? Are you using domestic manufacturers, international manufacturers? What are the pros and cons? Who's going to give you the best price? This can take a lot more time than you would think. Global logistics. Generally because of cost, sometimes because of availability, you may have parts being made overseas. Getting your parts from overseas into the US is a lot trickier than it sounds. You can't just ship them by UPS and wait for something to come through. On the same token, it's also difficult to export your finished product to other countries. So if part of your business plan is immediately selling to the US, Canada, Europe, Africa, Asia, you need to understand that it's a lot more difficult than just throwing something on Amazon or throwing something on a website. There are a lot of hidden costs, fees, and logistical nightmares when you're dealing with importing and exporting that you definitely want to be prepared for, and you want to have someone that has done this before on your side. And then lastly, contract manufacturers. So if you're not planning to spin up a manufacturing operation and hire people to assemble your product, who will? Who's going to do the assembly? Who's going to do the packaging? This is the final step, but also the most critical because all that work that you just did means nothing if it doesn't get put together in a product that has good quality that's ready to hit shelves. Okay, so I know I went through a lot in just a little bit of time here, but my question to you all is, where do you think most entrepreneurs fail in this process?
If I had to guess, maybe proof of concept.
Okay, that's a good guess. Anyone else have a guess? So, right here, the number one place where people fail is in understanding your customer. And the reason why this is admittedly a misleading and a bit of a trick question, because you generally don't fail at that point. You fail because of what you did at that point. You didn't understand your customer. And the worst thing that we unfortunately see is when someone goes all the way through this process and then they realize that they didn't understand their customer. They designed something that didn't meet their customers' needs or didn't pique their customers' wants. So what I want to start to talk about now, which is really the core of my message to all of you today, is capturing your customer feedback. What does this look like? What is an effective way to do this? What I'm going to share is one of many ways that you can do this. This is what we do internally here at Tresca. Find the method that works for you. My point is to show you a structured method that will allow you to do this. So what I'm going to be talking about here are user requirements and functional requirements. And to break it down pretty simply, your user requirements are the what. What does the product need to do? Well, it needs to be used this way, and it has to have these attributes. This is what your customer wants when they look at the product on the shelf. What you need to do as the designer is you need to translate those into functional requirements. Okay, so I understand that the user needs those 4 things. How am I going to do that? Well, I need to have the machine do this. I need to have it sized like this. I need to have all these different things. That's the how. How are you going to achieve the what that your customers ask for? In every user requirement, you need to cover them by at least one functional requirement, right? The basic sense of if a customer needs something to be done, you better make sure that you have a function to get that done, or explain to them or make a deliberate business decision that you're not going to be able to achieve that specific use. Sometimes you need more than one functional requirement to meet one user requirement. On the other side, sometimes you can meet multiple user requirements with just one functional requirement. Yes, this is very confusing. So what I'd like to do here is take you guys through a quick example of what I'm talking about here. So let's take the example of a water bottle. You're a consultant and you're starting a company and you're developing the latest and greatest water bottle, the next great one. And you have a user base that's telling you, hey, there's no water bottle on the market that does these things. So they're telling you, okay, listen, I need this product to hold as much water as a standard water bottle. I need it to be completely recyclable. I need it to be completely transparent. I don't want it to break if I drop it off a table. And I need these to sell for $10 each. You'll notice that none of these requirements are telling you how the product is going to work. They're telling you how the product is going to be used, the user requirements, right? So how would we approach this? We have this list of things that they want of the end product. They're not telling us, how we're going to be able to achieve those. So what is the what? What's actually going to be created? Okay, so we know that to achieve these, we need to create a design that holds half a liter of water. That's your standard water bottle. So we're translating that into something that we can measure and act on. Okay, well, we also have these requirements that it needs to be completely recyclable and completely transparent. How are we going to achieve that? Well, we can say that as a requirement, it needs to be constructed of clear PET, which is, by the way, the material that most water bottles that you use are made out of. Okay, well, they also said that they don't want it to break when dropped off a table. What does that mean? Well, that means we need to make a design that can withstand a drop while filled up with water from 6 feet without any breakage or leakage. And then lastly, one of the most important requirements, especially if you're selling a product, it needs to sell for $10 each. Okay, well, this probably has way more than 2 functional requirements, but the 2 I came up with here, all materials and components must be consumer grade plastics. We don't want any plastics that SpaceX is using that cost $3,000 a pound, right? And then aside from the main cap and bottle, we don't want to use any custom parts. Custom parts are expensive. We want to find stuff that is mass manufactured and off the shelf. So again, this is just a quick demonstration I have here of different ways that you can consider capturing user feedback and implementing it into functional requirements. Are there any questions on that concept?
Dan, I do have a question for you.
Sure.
So Erin Rowley is our librarian in engineering, and she often speaks of standards. I know you talked about patents, and she does a lot about that as well. But in terms of standards, do you use standards? Do you reference? And at what point?
Absolutely.
And can you maybe explain what standards are?
Sure. That's a great question. So standards are important because, and this is going to sound redundant, but they standardize things. There are a lot of things that would be utter chaos if they weren't standardized. So one of the largest standardization bodies that I'm sure some of you have heard of is ISO. They focus on quality management systems, but they also have generic standards. The reason why every credit card in your pocket is the exact same dimension is because there is a worldwide recognized standard for how big a credit card should be. Why is that important? Well, not just so that your wallet looks a little nicer, but any ATM, any vending machine, any gas pump, they all are designed to accept a specific type of card. So standards are incredibly important. important. And Hadar, to answer your question, understanding your standards is part of this, right? When we have an intake with a client here at Tresca, one of the first questions we ask are about standards. Their standards for sealing and IP rating is what people are most familiar with. Does this need to be waterproof or dustproof, water resistant or dust resistant? There are regulatory standards that are a lot around power requirements. So if you have a product that is taking in more than 28 volts, you need to get that UL certified, Underwriters Lab certified. And that is basically a national standard that is saying, hey, we've reviewed this design and it's safe for someone in their house to plug into a wall without zapping themselves, right? Understanding the regulatory requirements is definitely an important step, and this is the place to do it. One thing to mention too is a lot of you, if you're developing your own product, you're the ones that are making the user requirements. You may not have one customer that's telling you, I need X, Y, Z. You may have an idea, and part of your customer discovery isn't just discovering who your customers are, it's discovering what they want. And part of that is going to be involved in any standards you need to work on. Does that answer your question? Awesome.
Great, thanks.
Any other questions on requirements and capturing and translating them? Okay. So a couple questions to think about here. With what we've just gone over, how can you better capture your customers' feedback? How can you develop your product using customer specifications first? And then lastly, how can you adapt this design process to your business plan? As you're going out, as you're forming what you need to do to bring your product to market, how can you look at this design process and adapt it specifically to you? I showed 7 main steps. Maybe only 5 apply to you. Maybe you've already gotten to the point where you have a CAD model and you don't need to start with the first 2. All of that is customized. There's no cookie cutter process for developing a product. There's a reason that the process I went through seemed a little vague and seemed like there were a lot of gray areas. There absolutely are. Developing an iPhone from concept to finish is a lot different than developing a water bottle or an expo marker, right? So those are some important things to remember as well. So what I'd like to do next is show you a real world example of how we use this process with one of our customers. So I'm assuming that most people here have heard of ACV auctions. Okay. So ACV has been one of our clients for some time now, and we worked with them on a challenge that they had in their product. And really the challenge was car underbodies are a mystery box when you're buying online, which actually, let me take a minute and just give you the elevator pitch of what ACV does. ACV Auctions is an online marketplace for car dealers to buy and sell used cars. Right now, you would need to go to a physical auction to do that. And those can be far away. You don't know what cars are there. You have to bid, the old fashioned way. ACV's created an online platform so that users are able to bid in real time on cars from the comfort of their dealership desk, right? So one of the challenges they found is that they need to inspect cars before listing them on the website. Well, ACV is currently selling, I think, 20,000 cars a month. There aren't enough mechanics, and even if there were, they're way too expensive to send a mechanic out to every dealership every time a car needs to be inspected. So they need to find a workforce that is much less skilled and much less trained. To do that and still have it be effective, ACV needs to put tools in the field to help them accurately assess the value of a car, see any challenges or problems in the car. So they came to us with a problem. They said, hey, we can't really look under a car. We don't have enough time. If we're at a dealership listing 20 cars, we can't drive it into a lift and actually elevate it to look underneath a car. We need a better way to do this. So, a quick activity here. What are some ways that you see that you'd be able to use to solve this problem? Anything come to mind that would make you think, hey, I think there's a better way to do this?
It might sound crazy. I was thinking put the cars on a second floor of a building and have like a glass window looking underneath all of them. You can just go through and make sure they're all good.
Okay. I like it. Anyone else?
You could tell the cars to drive on like a conveyor belt that is on an elevated level so that you can just quickly glance underneath.
I like it. Okay. Those are two good ideas. So I'm going to walk through a little bit of what we actually came up with. And this is called the ACV Virtual Lift. So what ACV does is they're a software company. They came to Tresca because they don't have mechanical engineering capabilities right now. So they wanted to partner with us to work with their software team. What ACV found out is that if you hold an iPhone at a mirror at a 45-degree angle and take a video, they can actually stitch that video together into one big image that shows you the underside of the car. So they kind of came to us saying, okay, we have the general idea here. We know we need a mirror and a phone, and it has to be held at a distance. And then they came to us with all the other user requirements. Hey, this is going to be used all over the place. It needs to be bulletproof. Sometimes people are accidentally going to drive over this and we can't have it get crushed, right? That's where we started with the concept generation. We got the user requirements of phone, mirror, car, a whole bunch of other regulatory requirements. And then they said, okay, go figure this one out. So we had to do a lot of proof of concepts. I know it seems a little simple from that picture, but this was actually a pretty complex project with a lot of different subassemblies.
Playing from laptop N46T78.
So one thing I'm showing here is the battery holder. So there's a battery that controls the lighting on the virtual lift. You need to hold that battery in place. We had a custom battery, so we needed a custom battery holder. Sounds very simple, but the reason that you're staring at 17 different iterations, there's a lot of detailing that needs to go on. This is where 3D printing is critical. How is the battery going to snap in? Is it going to slide in? Is it going to clip in? Once we decided that it was going to snap in, hey, how thick should it be? Is this too hard to put in? Is this too easy to put in? There can be a lot of iterations in this step. And that's why I put a big confusing picture here, because this is part of the process. This is part of proving out the concept. Next, you need to take all those different proof of concepts that we were able to quantify and put it into one product. So we validated that everything was working separately. Now we were able to validate, hey, once we put everything together, it's going to fold correctly. It's going to have the right dimensions. There are no interferences. And by the way, here's how much it's going to weigh. We couldn't give them an 80-pound tool to carry around a dealership parking lot in the middle of August, right? That was another requirement they had. This also helps get you a better picture of how the product will look. We didn't have a full prototype of this yet, but we had this CAD model. That was enough to share with ACV's marketing firm to have the press release that they had just patented this. Oh, my picture disappeared. For simulation, we did a lot of FEA on the battery holder that you saw. So sticking with that as an example, it was great that we tested it, but we tested it with 3D printing. How do we know that in the next 2 years that this will be in use, these things all don't start breaking and cracking? Well, it's not really something that we can test. So we had to figure out different ways that we can simulate 2 years of use here. And I think I have, yep. So one way we did it is we calculated over 2 years. We think that the battery would be taken out to be charged about 600 times. So I paid one of our engineers in a case of beer to sit home one night and quite literally take this in and out of the battery holder 600 times. And we looked at the before and the after, and that was kind of validating our design. The reason I put this in here is to reinforce what I said earlier in the presentation. Sometimes you got to get creative. Sometimes things look a little unorthodox, but that's how you get to these solutions. Next, we move to the prototype. This was something that wasn't mass manufactured. The picture in the top right is a 3D printed part of something that would eventually be molded. We assembled the unit, we tested it, and we were able to get the first full virtual lift unit, virtual lift photo, and that's what you see right here. So this was a video taken in our first prototype, and they were able to stitch it together with their software expertise and come up with something that has never been done before in the auto industry. Now, if I'm in California and I'm buying a car from Buffalo, I know exactly what the underside of the car looks like, so that I'm not surprised when I get it and there is a bucket of rust underneath it after it's already been shipped across the country to me. And then there's the design for manufacturing part. With that image, we were able to show, hey, our product works as intended, everything's great. Then they turned to us and said, great, make us 1,000 of these. Well, okay, that was a lot of 3D printing. That wasn't ready for molding. That wasn't ready for intense machining. So one example I'm showing here is the end cap. A somewhat complex part. We needed to do what's called drafting. And I won't get too much into the technical details here, but drafting is something you need to do to plastic parts if you're getting them molded so that they can actually be molded without getting stuck in the mold or warping or falling out. That's that extra step where to the naked eye, it looks no difference, but the difference is it going to work or is it going to fail? And then lastly, we had to go through all of the activities necessary to get those 1,000 units into Buffalo. We had to create a bill of materials. I think there were 75 total components in the virtual lift. Every single item we needed to source, and we needed to find a contract manufacturer to actually put everything together. Logistics. Thankfully, this was right before COVID really started to get crazy, but there were local companies in Buffalo that contributed. There were domestic companies as far as California that we bought components from. And then we bought components from 3 different countries and got them imported into the US. Definitely I'd say arguably the most challenging part of this project was as COVID was ramping up, making sure that importing and exporting was still going to go somewhat smoothly. And yes, that was as fun as it sounds. So with that, I hope that this presentation kind of showed you a little bit of the core design process, the importance that I personally see on capturing your customer discovery and your customer requirements, and then a little bit of real world examples of how you would capture those and what Tresca did on a project. So with that, I know we have a little bit of extra time and I'd be happy to answer any questions either on what I've talked about, on the process, or on your own products that you're working on.
As an engineer, do you believe that you should learn how to use or you should learn CAD softwares as soon as possible, or do you usually recommend waiting?
So I think it all depends on what you are looking to do. If you're looking to start to develop products and tinker on your own, absolutely. This is something that is pretty easy to learn, to be honest. YouTube is your best friend when you're learning CAD. And it's something that's going to help you bring your concepts to life. If you're trying to get buy-in from potential business partners or mentors or investors, having something that you can take pictures of in 3D space is definitely a value add.
A question I kind of have too is, I know for me, I really like the business side and thinking about business, but the engineering stuff you kind of talked about goes way over my head. So what is your advice to someone who would want to open their own business one day, but doesn't really know how to design a product or bring things to market physically?
Sure. I think take advantage of your time at UB. There are so many students that are willing to collaborate, professors that are willing to mentor, centers like Blackstone that are able to help guide you in the right direction. One of my favorite parts about Buffalo in general outside of UB is the community here. There are so many people that are willing to help and give their time and pay it forward. And using the resources you have at UB is a great way to establish that network and get in touch with the right people. in my opinion, and I'm far from the first person to say this, but I know that I'm doing my job well when I'm the dumbest person at the table. When I'm surrounding myself by smart people and experts, that's when I know I'm making the right decisions. So my advice is utilize your time at UB to find those people.
Thank you.
I have a question.
Sure.
When you source your products, do they come from ethical places? Like, do you know who's making them, how they're made?
So that's a very good question. You do and you don't. You can do a lot of research. The bulletproof way is to actually go and get some, visit the manufacturer, visit their facility. Unfortunately, even that, to be honest, isn't bulletproof. You do need to be a little bit mindful. I know textiles is one where it is unfortunately a lot worse than many other industries. But yeah, there are parts that are coming from China that are not made in ethical ways. And something that is sometimes frustrating is I'd rather keep our business in the US. I'd rather support US manufacturers. Unfortunately, I also understand that our clients need to run businesses. They need to sell their product. I worked on a part actually just this week. It was a plastic part, probably similar to the size of this remote. And to get this molded in the US, it would have costed $7 per part. To get it molded in China, it cost 88 cents per part. Unfortunately, especially in plastics, which is what we work in quite often, there is an incredible gap between pricing, something that you can't always justify as, oh, I'm going to spend the extra $1 on my product to get it made in the US. Sometimes it quite literally makes or breaks your business plan, whether you're getting something manufactured overseas or not. And the number one reason that is because of labor rates, right? And that comes full circle back to the question of ethics. So it's a good question. Personally at Tresca, when we're sourcing things, we always try to factor that in. Especially in COVID times, I unfortunately can't get on a plane and visit all our manufacturers and make sure that they're operating ethically. It's definitely a challenge in the engineering and manufacturing space. But great question. Any other questions from anyone?
Maybe one more for me actually. I was just wondering, so I know as an engineer, you guys probably had to learn a whole bunch of softwares. For a business student who, hasn't really learned any softwares, what do you suggest are the best ones to learn if you want to start a business, create products?
I'm not joking when I say Excel. I spend probably 50% of my week in Excel, both for business side and engineering side. And really the reason I say that is because from a business sense and an engineering sense, numbers are everything. That's how you are going to communicate with your technical team. Numbers on cost, size, weight, all these different things. Engineers are quantitative people. It's arguably the worst part about us is all we think about is numbers. From the business sense, your job is to lead your engineering team, lead those smart people, give them the requirements, right? We talked about user requirements and functional requirements. The way that we sometimes work even internally here is I'm the user. I tell our team what our customer needs. They're the ones that figure out how that's actually going to be achieved.
Thank you. Yeah, that's really reassuring to know Excel because I feel like that's the one a lot of business students end up learning.
Definitely. Won't let you down.
I agree with that. I use Excel all the time. It has so many add-ons. And what I do, there's a really basic add-on called Solver that just optimizes everything. But with Excel, it's smaller scale.
Are there any final questions? Cool. Well, I want to thank you all for joining and taking the time and asking some really thoughtful questions. Hope you gained a little piece of knowledge that you didn't have here before. And Hadar, thank you for the opportunity to come out and present today.
Oh, it was our pleasure to host you, and it's always fun to see one of our own come back. So thank you so much, Dan. Really appreciate it. And let's offer Dan a virtual round of applause. Right? Can't get enough of the virtual applauses for sure.
Absolutely.
Have a great night.
Thank you so
Go
much.
ahead.
Great. Thank
Thank you so
everyone.
much.
And then for anyone left on the call, thank you for joining us. Just for your information, we have another workshop coming up on Thursday, March 25th, 5:30 p.m. Eastern, and that's going to be focused on financial projections for your startup. We also have some great events and competitions coming up, which you may have seen on the intro slides. A few of them being Empower Pitch, Student to Biz, and of course, Get Seated. There's also our venture coaching and any experts in residence being offered virtually, and Coffee Club is immediately after this. So if you would like an opportunity to network with some UB students, feel free to stay on the call, and me and Honore will be leading that.
Who's leading the financial projections workshop? And also, can I talk to them before then?
Let me check. I don't really know off the top of my head.
I don't know either. It's really sad, but I'm sure we can put you in touch with them in advance.
That's like our biggest lacking thing in our presentation.